Hi everyone, my name is Kush. Today I'll be walking through everything we've learned in web development so far. I'll be using one big metaphor to really hold this all together, which is a restaurant. A website basically is one. We have this entire dining room where the customer sees and will be sitting, and you have the kitchen area which the customer will not be seeing and will contain sort of the node.js, the JavaScript, and really the pantry in the back, which is like the database. And we have basically the other important elements, which are HTML and CSS. CSS is more like the ambiance, and you have HTML, which provides a lot of the structure and order and could really be considered as like the menu, which has a lot of the core content that we will be seeing. Now I want to sort of show this mind map that I've created to kind of delve and showcase all of these concepts in a visual manner. So first we'll be talking about the menu, which is really the structure of the page and really breaks down into four different parts, which we have the syntax, which is how the element's written, the page structure, the framing of the document, the content, which is essentially like the dishes, all the text, media, and forms that go on the page. And then you have the DOM, which is sort of this live page that JavaScript can rewrite to, and we can kind of also see as sort of the live menu in sort of restaurant metaphor, which is our first bridge into the chef, which is JavaScript itself. To go into sort of what the CSS is, it's the ambiance, as we said, which is kind of like the look, feel, and lighting. And there are different ways of how we will be sort of applying the CSS, which are three different ways typically, which is kind of inline that directly into the HTML page, which is like a node on a plate. You have kind of you see as like the room side or style block that'll be kind of usually in the head blocks of the HTML page, or it can be a different style sheet itself in which you use a link tag to go towards it. And then you have different ways to target it as well, which we'll be going into later. The layout, the polish, that's visual style, and then different shortcuts as well. Next is the JavaScript, which is like the chef. It's basically the part that really does these things. It covers sort of the variables and data, the way you work with the data itself, the different functions, which can help sort of provide the actual actions, different ways to make page react, different ways of like talking to the server, and the ways to sort of you can organize code around this itself. And it's really the brain of the kitchen itself. Then we go on to where the architecture, which is kind of everything behind the scenes. And really what really connects all this together is the HTTP protocol, which is kind of how the waiter will even take orders itself. And you have different order types, which is get, which is sort of just bringing in the data, post adding the data / dishes, put is like changing the data size dishes, delete sort of canceling. You have sort of a simple two-tier setup, in which you have just a basic counter HTTP server that can serve all the pre-made static front-end files to the client browser, or you can have a more full stack way of doing things, like a three-tier full restaurant, which you have the dining room, the kitchen, and the pantry. And as we said before, which is like the database, Node Express, client browser. And then lastly, sort of like good kitchen practices, around all this, learning how to build a full stack app through all these elements, which we'll use a linter, and then prettier is more for formatting, linting just more like syntax checking, different ways of providing accessibility, as we have certain like search engine optimization tags that we can look at. And then there's certain environment variables that you use when building these applications, such as like your connection string to connecting to the Mongo database. Okay, that's the whole map. Now let's go back through, open up each part, and explain how it actually works. And at the very end, I'll follow one real order through the entire restaurant so we can see how everything connects. So let's look at HTML and look at the syntax first. So basically, every element is a tag with a name and attribute. For example, you have the anchor tag, with the attribute href, which is really the hypertext reference to whatever link that the sort of clickable word will lead to. And typically you have different opening tag and a closing tag. Opening tag is basically like you have two different things, so you can put the text content in the middle. And closing tag, it'll just kind of be its own thing, kind of like usually like a link tag, right? Will just close by itself. And then IDs and classes are important hooks that we attach to these tags as well, where ID is unique, where you have one per page and per unique element, like a specific table number. And for a class, it repeats a category of a dish. And these will really matter because when we discuss later on, CSS and JavaScript both grab elements using them. As far as the page structure is concerned, the main document structure is usually you have the head, where it's like the prep notes. You add all the metadata. So you would add these meta tags talking about like the author, description, any icons for the page. If you want to add any link tags to source to your CSS style sheets or your JavaScript files. And then you have the main body, which is everything that will be showed to the customer and where everything is visible itself. And then within the HTML files, you have these semantic tags like header, nav, main section. These sort of add meaning to the content that you're displaying on the page. And it is very important for accessibility, such as if anyone who is blind is sort of reading off these pages, they'll know like which part is sectioned in what way. Then as far as the content goes, like their dishes of the restaurant, you have main headings that are provided, H1, H6. H1 be like very big, then it'll get smaller. You have paragraphs, P, and then you can provide lists as well. And essentially you will only have one H1 on your page, which is like sort of like the title of it. And then you got the tables, media, forms, which is how like a customer will place the order, which is through forms where you can provide kind of these text boxes or check mark boxes, etc., to input information, and then you can submit it. And then you have these div and span elements that I did not mention before, but basically div are like these block level elements that kind of matches the entire width of the parent. And then you have these span, which is more like these inline blocks. And they don't attach any meaning, but it's to help structure your information and apply like CSS styling. And that's as far as it goes. Next, we'll talk about CSS, the ambiance. We have the same HTML menu, but now we control how it looks and feels. You can apply it in 3 ways. You can apply it inline, a style tag, or really best practice, a link style sheet. You typically target what you want to style using selectors. So you would kind of have the type of selector, then a property and value. And then the different selectors are like element selectors, class selectors, ID selectors. And then with this, specificity really matters a lot, in which typically an ID selector would be the class selector, which would be an element selector, and then the order would win after that. And then you have different combinators, special syntax to kind of combine multiple selectors together. Could be descendant type, either, if when like 2 elements are adjacent to each other, or at one element's sort of direct descendant of another element. And then you have pseudo classes that are kind of like your guest interactions, which is like, styling something based on user interaction. Like if you're hovering over element, or you have pseudo elements where you're styling a specific part of an element or inject content that wasn't there. Like for this before, you would insert content right before an element's actual content. As far as the layout goes, it's very important to understand this box model right here, which tells you like for each element, you kind of have this margin, border, padding. Flexbox and grid are kind of more modern tools where Flexbox arranges things in a line, while grid is kind of more 2-dimensional layouts. Then responsive design is when like you have the same site rearranging for a phone versus a desktop. They have additional things like positioning and z-index as well. As far as your polished visual style, this kind of adds kind of like a lasting finishing touches, add colors, typography, transitions, transforms, shadows. As far as shortcuts go, you can have pre-built libraries that can provide you the components right away. So you have Bootstrap, just one type of like sort of pre-built design kit. An important rule to know is like that you have hashtag important, which if you add it, overrides everything, but you typically don't use it in standard industry practice. Now we'll go on to speaking about JavaScript, the chef. This is where the page will actually start doing things. So variables and data, quickly on the basics. We store values in different variables. The types could be const, let, or var, which we typically avoid. Const means you just can't reassign it, and constant let is block scope, while var is usually globally scoped. For the different data types, you have string, number, boolean, null, undefined, object data types. And then important thing to know in terms of operators, like the equals, the triple ones, where it checks both value and type, versus the 2-1 is just only checked the value itself. And then you can have strings and template literals as well, which usually uses some sort of like backtick notation. And then you can kind of substitute something in brackets with, whatever variable that you put into it. For handling data, typically you have like arrays and objects. Arrays are ordered lists, while objects are labeled key value pairs. Your kind of power tools are kind of like map, filter, reduce for each, in which map transforms every item, filter keeps the ones you want, reduce kind of boils the array down to like a single value. That trio kind of replaces a lot of loops in general itself, but the loops you kind of have 4 of for arrays or 4 in objects, and then you can apply kind of destructuring as well. If in the parameters you directly put an object with some variable names, or you put an array so it can spread out the values once using a function. Functions are the most important part. It's these reusable recipes per se. You have a classic form or the arrow form. Here you have the kind of closures, just kind of like these private stations that keep private nodes. and essentially it's a function that remembers where it was created. Then you have classes that are kind of like templates for making similar objects or your dishes. It has its own constructors and methods, and you can extend it. And then there's certain error handling aspects as well for functions like try catch. Finally, now we're kind of go to like the heart of it, which is sort of like making the page react. JavaScript will typically listen for some sort of event. It could be like a click, a form submit, or some sort of key press, and you would attach like a listener to it. Like when the guest raises their hand, you do some sort of code running for it, and then there's the interactivity part in general, which that's what it is. In terms of like then you would kind of talk to the server. This part's pretty much like asynchronous, in which some things take time, so JavaScript doesn't want to freeze while it waits. So a lot of this kind of handled in a couple ways. You have like promise objects, which kind of like IOU saying I'll get back to you, and then you would run like a dot then or a dot catch depending if the promise state either went from unfulfilled to resolved or rejected. And then for async to wait is a very newer way to do it that came to ES6 specification, which is a clean way to handle it. A wait keyword is when you have like a function that has the keyword async, then you use a wait on an asynchronous operation, which functions like a dot then. Then you kind of have the fetch API, which is pretty important with sending requests to a server or even like another page, and typically that data will travel in this sort of data exchange format that is language agnostic called JSON, JavaScript object notation, which sort of, as is in this word, looks like a JavaScript object, and it's very the same shape that MongoDB, which we'll talk later on, stores as well. But it's this common language of the whole thing will speak in. And then in terms of organizing your JavaScript code, it's usually done in module mode using import, export, name, deload, and loading JavaScript can be done kind of inline in the document or through kind of the script tag in the head HTML tags that we talked about before. A quick but important concept I want to talk about is the DOM, the document object model, which really bridges our HTML and JavaScript. To clarify, the DOM is a translator that turns your raw HTML into a live interactive tree that the JavaScript can read and modify to. There are three parts to this name. The document, when the browser loads the page, it reads your HTML file. You have the objects. It turns every HTML tag like div or p into an object, a piece of data with properties you can change. And then the model, in which it arranges those objects into a giant branching tree, showing exactly how everything is nested. So really in our terms, HTML is this printed menu that is fixed on paper. It's a static file. And then the DOM is this live menu the chef can actually edit, in which JavaScript can add, remove, update items on this tree in real time. And to have a more important note, there's one catch that sets up everything next, in which these changes aren't really permanent. Refresh and the DOM resets to the original HTML. To make changes stick, you send the data to a server to store, which is exactly where REST APIs will come in, and that's sort of what I'll be deep diving in later on. Next, I want to move on to the operation of this restaurant, the really architecture application, aka the back of the kitchen. There's a lot to go on here, so I'll walk the pieces quickly and show how they're laid out, then go back deep onto one of the concepts called the REST APIs in the next section. So let's talk about HTTP protocol, which is how the client, aka the browser or diner, and the server, aka the kitchen, talk to each other. And typically it revolves around these four main verbs: get to bring something, post to add, put to change, and delete to cancel. And typically when in communication, you have something called the request that is sent from the client and response that is sent back from the server. And this will be sort of made of the headers, body, URL endpoint, and the request you typically have like query parameters as well. And typically you have status codes when these responses are sent back to indicate, if there were any errors or how it was served, like for not found or 500, there was some sort of internal server error. And then you have these REST principles, kind of like the standardized way they communicate with each other, which I'll delve in later on. And then other major key concepts: authentication, error handling, rate limiting, and CORS. Next, I want to talk about the two architectures around this. You have this simple two-tier in which you just have this customer and the counter, in which you just have like a server that presents these pre-made static front-end files. And then you have a three-tier, which is really like the full restaurant, right? The client is in the browser, the kitchen, which is the Node Express, and the pantry, that's the database. To delve deeper into the three-tier architecture, let's start talking about the client, which is the customer at the table. And then you have Node.js, which is the kitchen itself. It's what runs JavaScript on the server. It's non-blocking, so no one process juggles many orders. And you have an NPM, typically Node Package Manager, that manages all the tools. Next, we have Express, which is the kitchen's workflow. It's a framework that rests on top of Node and typically wraps around the Node's HTTP module. Two important things to know about Express is you have routing and middleware. Routing is when it's like sending each order to the right station. You would typically say app dot one of the post methods, specify the path from the URL endpoint, and then have some sort of callback function that takes like some request and resource. Then you have middlewares, which is very important. It's like the prep line that every order passes through before the main kitchen. And each middleware function runs in the order it was registered. And typically the callback function needs to additionally take it next, in which you will call .next to go to the next middleware function, unless in that function you do some sort of completion operation like send a response. And then you have the rest of the anatomy revolving around, Express here, like request response, static file, JSON parsing, endpoints, etc. Next, I want to talk about MongoDB, which is like the pantry. It stores documents that are basically JSON, so the same shape flows end to end. You can perform CRUD operations like insert, find, update, delete. That maps right onto the HTTP verbs, and everything else is for querying the pantry that is around here, like the operators, aggregation and pipeline, indexes, and deployment. And then next, I just want to briefly mention React, in which you have a 3-tier architecture plus React is where the front end is like assembles plates at the table. Now let's talk about the payoff and how it all connects. Let's follow one order through the entire restaurant, front to back and back again. So first, a customer will click place order. A JavaScript event would fire. The code would read the form of the DOM, the document object model. Then it would be packaged as JSON, JavaScript object notation, which is like the order ticket. Then you would use the fetch API to send a HTTP post request, which is like the tickets carried to the kitchen. That would go to the backend, the server, or the kitchen. And then it would reach the kitchen, and then Express routing would then send it to the right handler, which is like the kitchen sending it to the right station. And then it would first pass through middleware, in which it would typically, you would have any logging done. It would have some data validation, which is the checked part, and then you have parsing of the JSON data itself. And then the handler itself would hit the MongoDB database typically if the handler required it. So you would perform some sort of CRUD or insert operation, which is like pulling from and stocking the pantry. And then basically you would have a confirmation from the database, and the server itself would confirm this order was processed through properly, and send typically a 200 status code and the JSON messaging, which is like sort of like the plated dish leaving the kitchen. And then you would have some sort of async code that in the browser area that is waiting on that promise object resolving, which was where the async task was initiated initially. And then finally, the JavaScript would update the DOM and have maybe some message like order confirmed, and you would have some CSS styling, to sort of show like, okay, this dish has been served and it's beautifully plated. So really, one click, we touched JavaScript, the DOM, HTTP, Express, and MongoDB, and then came all the way back, front end to network to back end to database and back to the screen. So that's really like a full stack application, the whole restaurant working as one system. Next, I'll be focusing onto one piece of this, which is the REST API, which is akin to like the service window where the front end and back end actually talk. And I will sort of build one live and do a code demo. For my deep dive, I picked REST APIs. In the restaurant metaphor, REST is the rulebook the waiter and the kitchen both agree to follow. It's the layer that turns raw HTTP actions into an organized, predictable conversation. By the end, the one thing I want to stick with everyone is this. HTTP gives you the verbs, but REST is a convention for how to use them. Let's untangle it. First, the problem REST solves. Your front end and back end are basically strangers. Often different teams, different languages, different machines. The front end needs to ask for data and send new data. But how should it ask? Where does it send the request? What comes back? If every backend answered that differently, every frontend would relearn the rules from scratch. That would just be complete chaos. REST is the agreement that ends it. It's a set of conventions, not a library as many people misunderstand it as, which basically says, here's how we name things, here's how we ask, here's what you'll get back. It's the difference between a restaurant where every table invents its own ordering system and one where everybody uses the same tickets. This is the most important slide, so I'll slow down first. First, what REST stands for. Representational state transfer. It's a style for designing APIs over HTTP, and that word over matters because HTTP and REST are not the same thing. HTTP is a protocol your browser already speaks. It hands you a few verbs like get, post, put, delete, plus status codes and headers. Think of those as the physical things a waiter can do: carry a plate out, take an order back, clear a dish. HTTP gives you the raw moves. REST is the etiquette on top of that. It decides how those moves map to what a customer actually wants. Name your data as nouns, use the right verb for the right action, don't make the kitchen remember you, send everything back in a clean shared format. So HTTP is a toolbox of verbs, and REST is the agreed way to use that toolbox. You can use HTTP without REST, but it'd be like a waiter who can carry plates but ignores every rule about which table they go to. It is possible, but it's essentially unreliable. Let's go over some of REST core principles, which are the rules of the restaurant. REST isn't vague. It's a strict architectural style that's governed by formal constraints. In order to understand them, we need to think of a restaurant. First is client-server separation. Just like a separate dining room and kitchen, your front-end user interface and back-end database are independent. You can overhaul your UI without breaking your data storage. Second, you have stateless. The back-end server remembers nothing between the requests. Every single HTTP request from the client must contain all the data and authentication needed to process it. It's like the kitchen not remember anything between the tickets. Third, you have the uniform interface. Everyone uses the same standard tickets, meaning developers use standard HTTP methods like get, post, and delete across predictable API endpoints. Finally, the data itself must be cacheable, so the client can reuse the saved server responses instead of making redundant network calls. So like if a dish won't change, it keeps a copy instead of reordering it. And then it's also a layered system, meaning traffic can route between intermediaries like load balancers or security proxies without the front end ever knowing. So it's like a host can stand between a customer and kitchen, and the customer would never know. So if you follow these rules/principles, then any front end can seamlessly talk to any backend. Next, let's talk about endpoints, which you can think of as the physical service windows at a restaurant. The absolute biggest rule in REST is how you label these windows. You name them after nouns, never actions. Each data resource gets its own unique address. For instance, you can walk up to the /orders window to see the whole collection of tickets, or the /orders/3 window to grab one specific order. The trap people typically fall into is writing /get_order. That is a mistake because action doesn't belong on the signage. Think of a real kitchen. The window is labeled by what is there, like the grill or the salad station, not by the task you are performing. You bring the action separately using standard HTTP verbs like get or post. You go to the grill window and get a burger. You don't build a separate window for the act of cooking itself. Now let's look at the two ways to request data from an endpoint because they do completely different jobs. First, we use path parameters to identify one specific item. Writing /order/3 fetches order number 3, acting exactly like a table number pointing to one exact spot in the restaurant. Second, we use query parameters. These come after a question mark to filter down an entire collection. Writing /orders status = pending asks the kitchen for only the orders currently pending. A simple rule to remember: paths pick one, while queries narrow down many. It's the difference between asking for order number 3 versus requesting all the vegetarian dishes under $15. Same kitchen window, but two different questions. Let's look at how this works in practice using the kitchen order system as our metaphor. This table presented maps our standard HTTP verbs and endpoints directly to real-world kitchen tasks. If you look at the rows, first, a get/orders lists all entries, which is simply like viewing the whole menu. Second, a post/orders adds a brand new entry, which means we are firing a new ticket order to the kitchen line. To target something specific, a get/orders/3 retrieves a single entry, just like viewing a specific dish on the menu. If we need to change that data, a put/orders/3 updates it, meaning we modify a cooking dish. And finally, a delete/orders/3 removes it, which is how we trash the ticket entirely. As you can see, the noun endpoint stays the same, but the verb changes the entire intent. Here's a deeper distinction most introductions typically skip. Some orders are safe to repeat and some aren't. First, get is safe. It only looks and never changes the kitchen state, so you can check the menu 100 times with zero side effects. Second, put and delete are idempotent. That's essentially a fancy word meaning if you execute them twice, you land in the exact same place. If you update order 3 to pizza twice, it's still just one pizza. If you delete it twice, it's still gone. But post is neither. Fire a post request twice and you're mistakenly placing two separate orders. Why do we care? Well, if a network hiccup causes a silent browser retry, a repeated get or put is completely harmless. But on the other hand, a repeated post can literally double charge your customer. Knowing these properties is exactly how you avoid critical system bugs. So what is actually contained inside one of these HTTP requests that will be sent from the client, such as the browser? It breaks down into three core components on our order ticket. First, you have the method and the URL, which is seen here as post/orders. This tells the server exactly what action you are performing and where to direct it. Second, you have headers. These are special instructions for the ticket or for the request. Most importantly, the content type header will tell the kitchen, hey, the data coming at you is formatted in JSON if you put this content type header. Then third, you have the body. This is really the payload containing the actual data, which is like our JSON object showing a new order for a New York style pizza at table 3, for example. But remember, a GET request usually carries no body because you're just looking through the service window. But a POST request always carries the raw ingredients of that brand new dish. Now that we've looked inside a request, let's circle back to statelessness. In a RESTful architecture, the backend server keeps absolutely no memory of you between individual requests. Because of this, every single incoming request has to carry all the necessary details. The server needs to process it entirely on its own. Think of it like a kitchen that refuses to keep a running tab. The cooks don't remember that this is the same customer from table 4 who asked for extra spice earlier. Every single ticket that's dropped on the rail must be completely self-contained and list everything from scratch. But why do we force this constraint? Because it allows our application to scale. Since no session data is trapped inside a single machine's memory, any backend server in our cluster can instantly pick up any request and handle it perfectly. Once you send a request, what actually comes back from the server? A REST response contains two core things. First, you have the data itself that is usually formatted as JSON. Because JSON is just plain text, it acts like a neutral piece of paper that any programming language can read and understand. Second, you get an HTTP status code. You can think of these codes exactly like the traffic light shown on the slide. They tell the front end instantly how to react, and they come in specific numerical families. You have the 200s, which mean green light, so success like 200 okay. 400s mean yellow light, a client error, meaning you messed up the request, like a 404 not found. And 500s, meaning red light, a server error, meaning the kitchen itself broke down. One quick glance at the code tells the front end exactly what to do next. So finally, how do you test a REST API before building a front end? Testing GET requests is actually easy. Your web browser executes a GET every time you visit a URL. So you just type the address and read the raw JSON response. But the address bar can only do GETs. You can't fire a post or put there because you can't attach a data body or change your verb. For state-changing operations, you need a dedicated tool like Postman or VS Code REST client. Think of it like trading up from just staring through the service window to holding an actual order pad. These tools can help let you pick your verb, write a JSON body, and fire it up. So let's recap REST in one breath. HTTP provides the verbs, but REST gives us the rules to use them well. We name our endpoints as nouns, pair them with the right HTTP methods, keep every request stateless, and pass data back as JSON typically. You can test your GET request in the browser, and you can test your POST request with a tool like Postman. Now I'm going to jump into a live demo using Express to demonstrate REST APIs. Now that we have done a deep dive, let's build some real REST APIs. I've created a small Express backend for our mock restaurant application. I've pre-written the setup so we can just focus on the roots. Just for a quick tour, I imported Express and created the application. This line right here, app.use express.json, is really the middleware that lets Express read a JSON body off a request, in which we would later need it for post request. Then I loaded the orders.json file, which is my stand-in for the database right here. But in a real app, this would be a MongoDB connection. But as you see here, we already have two orders on it with the ID, table, dish, and status. And then once we sort of run node server.js, the app.lesson will essentially create the server at the port 3000 on our local host. So we're going to follow one order through its whole life. We'll get the orders, place it, update it, cancel it. So now let's write the routes. First, we'll do the get, which is essentially reading every order, like glancing at the ticket rail. Get essentially means like bring me what's there, and it never changes anything. So you would do run app.get. You would put the URL endpoint /orders. Then you need to add in a handler that would take in both the request and the response. This is sort of the callback function that will be called when it reaches its endpoint. So let's define what's going to happen in that callback function. We would essentially just send the orders back in a JSON orders array. So there's orders. And that would just essentially be the whole read. So let's test it out. First, we'll open the kitchen, which is essentially our backend, which is pretty easy to test. So node server.js. This kitchen is open. This file right here will help kind of act as sort of running the request like a browser would. So send a request, and we see it went well, and we got both of our sort of IDs right here. Now let's move on to post method, which is placing a new order, handing the kitchen something to create. So there are two differences from the get method in that the verb you're now using is post, and this time we would be reading the data off the request. So let's start writing it. App.post. The endpoint is the same noun, but it's sort of like the same kitchen window, but with different intent. We make sure to specify our callback function that takes in request and response. And then we will now building the new order. So we need to make sure, like in a real database, you would have an ID that would be sent in the database. It would not be sent in the request. So for now, we set it sort of based off the current length of the orders array. So orders.length +1. But the table and dish, that will come from the request object from its body property. And that request.body, that's the JSON the client is sending us. And we can only really read it because of this express.json function in the middleware app.use up top, in which it goes through that middleware first before getting here. So table will be request.body.table. The dish is similar, request.body.dish. And then for the status, we would set it to its default for now, which would be cooking. So then we will be pushing it onto the JSON orders array. So orders.push new order. That's in memory save, but in a real application, this line is really where like a MongoDB insert would go. Then we need to make sure we just send a proper status code response. So response.status 201, which specifically means created, not okay. And we would send the order back. So new order. And then let's test this out. So let's restart the server. Go to our REST client file. So we know the browser can't help here because it only does gets, but here's our post test. So we got the post verb, it declares a JSON body and carries the new dish or mushroom risotto. So let's send the request. We see it went properly. 201 status goes created. Essentially the kitchen handed back our new order as number 3, table 9, with the dish mushroom risotto with the status cooking. So this was done right. So now that our risotto dish has been cooking, let's mark it as served. We would do that through the put method, in which we would be updating something that already exists. So app.put. So in our endpoint, we would do /orders/:ID. That is a new thing. That's basically our path parameter, like I saw in the URL. So I'll show later how we're going to access that requested ID that we want to modify. So request response. So we would iterate through the orders. And then in those orders, we would try to find the ID that matches the requested ID. So we would call the .find array method. So we would loop through each item and then do a comparison if the ID matches the requested ID of the item that we want to modify. That params that ID. And then if the order is not found, we would essentially return a status code called 404 not found, and then some sort of message we would say. You can say like order not found to be more explicit. If you do find the order, we set the status to whatever was given in the request, and then we run. We give a JSON back of the order. So now let's test that out. Send the request. we see successfully we have changed the status of the existing item with ID 3 of the mushroom risotto dish. If we want to try where something, if it didn't exist, we would do this and get a 4 for not found as stated. So now to demonstrate the last method, which is the delete method, say a customer wants to cancel an order, we would then define app.delete, put the endpoint in which we want to target a specific order, in this case by ID. So you would put the query parameter for that, :ID. So let's specify our callback function. Similarly, we would kind of find the order how we did before, where we find based off that. So we can just push this over here and then do a similar item potency check as we did before. If an order was not found, this we can kind of be more specific, like for delete operation. And then say we do find the order, we basically want to filter the orders array down everything except this ID, like trashing the ticket, and send back some confirmation. So do orders equal orders.filter method, where for each object there, orders ID not equal to params.id. Simple. And then send some JSON message back. And then we do is use a template literal form to put the specific ID. So order, then you would use this bracket notation right here. Request.params.id was canceled. And this red line is just forward prettier. So now let's test this out using our REST client. So first show this exists, ID 3. I'm deleting this ID 3 now. And it worked, 200 okay, message order 3 canceled. Awesome. And then just to show the 4 for not found, if I add in like 3 again, it would basically say that. And that shows the item potency. With delete, if you did it twice, it would show the 4 for not found. But with post, if you did it twice, it would put 2 orders in. So that's the full REST backend. We took one resource /orders and ran it through all 4 HTTP verbs. We did get to look at the ticket rail, post to place an order, put to update it, and then delete to cancel it. We really followed one single ticket from start to finish, all in JSON using real status codes. So this really takes the whole concept matrix from the deep dive slides and puts it into actual running code. And using this restaurant setup, the tickets, the kitchen window, the order rail, it was kind of my way of like extracting these backend rules and turning it into something you can actually picture. So that's the full life cycle. Thanks.